So if you remember in the last session we talked about how to convert an RDD to a data frame. The reason being sometimes the data source API may not be able to custom parse your data. Wherever there is a custom parsing of your data is required, the data source API not do very well. In that case, sometimes we have to fall back to RDD, because RDD is just like writing the Scala code. So you can write your own parser class. Inside that you can have some parse method, do all kinds of custom parsing. Finally, you will get an RDD. Once you get the RDD, so there are ways you can convert an RDD to a data frame. So first, last session we saw how the case class work. Just case class, not to worry about that extra jargon case. It is nothing but a class with some built-in methods by the compiler. Compiler has already built in some methods like toString method, equals method, hash code method, and some built-in apply method, unapply method. Some constructors are built in, which are the members. Members are made as val by default. So those things are done by the compiler. Otherwise, there is nothing concept related things with respect to the case class. Just imagine it as a class with some built-in methods that is being used to convert an RDD to a data frame. So your RDD should be each record of your RDD should be an object of some class. So when it is an object of some class, then the members of the class is treated as the column, and the data types of the members are treated as the data types of the column. So from there, it extracts extracts the schema, and your data frame is ready with your data now. So that's what we saw in the last session. So just to show it once again, so as we saw, we read our data using the text file API, and we know that our data also contains the first line as the header. Hence we have to remove the header, because RDD will treat header also as a record. So hence we have to remove the header. So we yesterday saw, last session we saw how the map partition with index works. It's just like the map partition, but also we have the numbering to your partition. Then we converted our RDD of string, because when we read it through text file we get an RDD of string. RDD of string is transformed into RDD of sales. We want to convert each record from a string to some class object. So we can see here it is RDD of sales. Then you just use 2df function, which will convert an RDD to a data frame. So in the last session we saw that, I don't know whether I ran that program. Let's run this program and check the result. So meanwhile, we also saw how multi-line JSONs. I didn't had the code, but I showed you how the code can be integrated. So if at all that also you want to convert into a data frame, so that also we can do. So let me open that Spark core. and run that as well. So we have our JSON input format, but we chose to use the RDD API just for understanding purpose. We read the data using the new API Hadoop file because we will be using the JSON input format. Here we transform this into an RDD of JSON record after reading the data. So we have RDD of sales record. Then you just call 2df function. It's JSON data and we can convert into a data frame. Similarly, your multi-line JSON record could also be converted to a data frame. Only thing is you need to use multi-line JSON input format and their long writable as the key and their corresponding as the value. You can check that code in the GitHub. So once you have an RDD, then just convert into a case class and get the schema out of that case class and then convert into a data frame. So both should work. As we see here, this is our sales.csv. This is our sales.csv. We are able to convert into a data frame. Similarly, okay, I did not give the input commands. Code source main resources sales.csv. So let it run. So I hope till here things were clear. Either you read the data through the data source API and get the data frame, which is the simplest way, and 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 it's by default kind of, and not some custom things can be done very easily. So that's where whenever we want the custom things, we fall back to RDD, then convert that RDD to a data frame. One of the way is through case class. On case class, we use the 2df function. 2df is generic. 2df is generic here. In either case, we can use the 2df. Now we will see the one more way of converting an RDD to a data frame. So this also gave the same result. Oh no, there was some error. Did I give here CSV or JSON? My mistake, because I'm using a JSON input format. I should read a JSON file. Okay. I think I did not do the show here. My mistake. I converted into a data frame, but did not do anything. Val sales df will say, then sales df dot show. We know that show is an action, otherwise it will not do anything. So as you can see here, we got the same thing by using our custom input formats. So any custom input formats you can write, then finally you can convert that into a data frame. That is also possible. Usually for multi-line JSONs, you may have to write this. Otherwise, most of the time, VV or data will be in the normal form. Mostly we write the custom input format mostly for multi-line JSON. Otherwise, it will be the normal cases. Now, next what we'll see is one more way of creating a data frame using a structure type. So usually this structure type is also called as programmatic schema. Now, what do I mean by programmatic schema here? Any guess on what do you mean by programmatic schema? Uh, Defining custom schema. Okay. I mean, we can define any schema using the case class, a class inside a class inside a class. I mean, one of the member itself could be a class. We can define a custom schema using normal class also. Programmatic schema means you specify the schema dynamically. That's the difference between creating a data frame from a case class RDD and creating a data frame using the structure type. Structure type are programmatic schema. What I'm trying to say it is a dynamic way of specifying the schema. If you see the case class is a static way of specifying the schema. You are hard coding the schema, hard coding the schema. I think I will show a simple example first, but it may not give you the use case. What difference does it make if we give in this fashion or case class, that you may not be able to know by this example, but just for syntax purpose I will show that example. Next example I will show what would be the use case or what is the difference there. So you have to search for in Spark SQL project, search for programmatic, search for programmatic schema. And it uses the structure type. So this is how you specify the schema. As usual, we are creating our Spark context. We can also create our Spark con. We know that the data type is not necessary. We can skip this and create the Spark context with the help of Spark con so that the deprecated APIs are not used. When we say a scratch mark, we know that it's a deprecated API. Now this is how you specify the schema using the structure type. Using structure type. So every field, every column name should be specified as this. Transaction ID in this fashion. And its type is integer type. This is the data type that we should use in the Spark. You cannot use a normal int, double, those things. Spark has its own data type here integer type, double type, string type, date time, timestamp type. So those are the supported data types in Spark. So you have to create something like this. Struct field is the one we should use to create a column name. First, it takes as the column name, transaction ID. Its type is integer type. The third one is whether it could be null or not null. So similarly, we want four fields. All the four fields we want here. Nullable item. Sorry, my mistake. Whether it is null or not, we just have to say true or false. True means this value could be, the value of this column could be null. Now similarly, I want four such fields. So four such fields will be kept in an array. So you define an array and you put these fields in an array. This is the first field, second field, third field. Now we have the fourth. So this is how you define a structure. Transaction ID, customer ID, item ID, amount paid. So these are and amount paid will say it as a double type. And we just close the array. So this is how you define the schema fields. All the fields of your schema will be in this fashion. Then wrap this inside a struct type. Wrap the whole thing inside your struct type. So this is your schema is ready. So that's how you specify the schema. So you read the data. You read the data. I will use this later. So we read the data using the text file API. We get an RDD. As usual, we are removing the header. You can just put these things inside one method and always call that method. So instead of rewriting again and again these things, you can put these things in some utility method, remove header, and you can always call that method. So once we remove the header, here the slight change is you have to transform your RDD of string to RDD of row object. That's the difference. In case of taking the schema from the case class, so you had to transform an RDD from RDD of string to RDD of class. But here, when we use the programmatic schema, we transform our RDD from RDD of string to RDD of row object. So you have your RDD here. This is your record 1, record 2, record 3, 4, record 5, and so on. So you have to transform. When we say transform, obviously we'll be using the map hierarchy function. So record, it is a string. So it has to be transformed to a row object. Each record is a row object. I will say row 1, row 2, row 3, and so on. Because internally when we say a data frame, the data frame is always represented as a collection of row objects plus schema. Data frame is always in that form. It is a collection of row object plus schema. Internally it will not be any case class object. Internally it will be a row object itself. So just to clarify that, we use the case class, right? So our RDD was, we used our case class. There our RDD was RDD of sales, and that we converted into a data frame. From the data frame, we can always get back the RDD. So we have our sales DF data frame dot RDD will give you the RDD that we use to create the data frame. So I will say sales RDD equal to this. Now if I check the data type of this RDD, to check the data type of RDD, we have to hover wherever it is being used. So you can see that once you convert an RDD of any form to a data frame, internally it will be RDD of row itself. So just before converting RDD to data frame, it was RDD of sales. So now if you see, it is RDD of row object. So there is a class called row. So each record will be an object of that row class. Internally it will represent as the row object. So when we use the struct data type, when we use the struct data type, we have to transform our RDD from RDD of any form to RDD of row object. So here it takes three fields. Any number of fields can be specified. So here our data has three fields. First field is transaction ID, second field is customer ID, third field is item ID, fourth field is amount paid. So then just we use create data frame. Pass that RDD, which is RDD of row object now. We converted into a row object. And schema, we created the schema in this fashion. And let's see how it looks like. We created our data frame using the create data frame, and let's see how our data frame looks like. So that's our programmatic way of creating a schema. Now, can you say what is the difference here? When to use what? When should we use the case class? When should we use the struct type? I mean, we cannot know from this example. Both looks almost same. I can either use this or I can either use the case class. What difference does it make? How can I say this is a dynamic way of specifying the schema? So this example doesn't say that it is a dynamic way of specifying the schema. So the next example we will see that will give you the difference of what is the difference between case class and the struct type way of specifying the schema. Now as you can see here, transaction ID, that's what we have specified, cust ID, item ID, and amount paid. So we were able to specify the schema and their corresponding data type. Now let's see what is the difference now when we should use the case class and when we should use the struct type. So to understand that, you need to have just check whether this piece of code is available. I don't remember whether I created the image with this piece of code or not. Please do check, otherwise I will share this example. Now the question is if at all you have your data in data in one file and schema in another file, just like in this fashion. So I think it took it from no. Yeah. So if we have the data in sales.csv and schema is somewhere else, so you have to use that schema. So you cannot dynamically say case class. You cannot define a class based on some condition. Classes you define just statically. You just define it at the upfront itself, from the starting itself you define a class. Have you ever defined the class based on some condition? If this is the case, define this employee class. If this is the case, define some department class. We never do that class definition dynamically. But if you want to dynamically assign a schema, class definition is not possible. So one of the example is your header is in one file, your schema is in another. I mean your data is in another file. So just to show that. So this is our schema. Okay, I will send this through mail. So this field has only this file has only the schema, and which file we were looking into. My mistake, sorry. Sales.csv and sales header, just sales header. Do you see sales header is here? Yeah, as you can see here, this file has only header. Transaction ID is of the type integer, customer ID is of type integer, item ID is type integer, item value is of the type double. They have only specified the schema here. And normal our sales CSV, not sales CSV. What is that? Yeah, sales CSV itself. Sales CSV. Now here, how do we associate? Let's say this does not have the header. We are assuming that this will not have the header. Header will be placed somewhere else in other file. Now how do we get the data frame out of this? So this is where that programmatic schema or the struct type comes into picture. So you read the file first and prepare your header. Which one I'm using? This is the one I am using. Get schema from column and type. From column and type. So you specify the file. We use the normal Scala API. Scala.io is the input-output operation package in Scala. We read that file from file and give the file name. We read that file, get all the lines, get the lines, and these are the lines here. Convert into an array. We are converting into an array. We are also removing the extra spaces. This is also important because sometimes what happens, if you have some extra space here, if you have some extra space here, it will treat this as the column name. This will be your column name. If you just give select trans id, it will not recognize this as the column name. So that's the reason some extra spaces are being removed here. We have an array. We go through each element of the array. Each element of the array will be in this fashion. So we have our array now. It has trans id int, cust id int, item id int, and item value I said is double. So this is our array now. Now this array has to be transformed into a struct field. It has to be transformed into a struct field. So obviously we'll use a map higher order function. Take each take each element, this is one element, and transform into a struct field. So that's what we are doing in our next thing. Remove the extra spaces. After that, take each element, split it by space. Because if you see each element, we have name and data type. You have to split it by space here because we have space here. So this will be the column name. This will be the column data type. So that's what we are doing. We return column name and column data type. So if I hover on this, it will be an array of name and data type. Name and data type. Go through that each record now, which is a tuple. Take each record is a tuple, convert into a struct field. We know that struct field first is the column name. So t contains the t is a tuple. T dot underscore one will give the first element, which is the column name. The t dot underscore two is the second element, which is the column data type. But if you see the data type, it is in the normal language, int. But Spark does not understand int. Spark understands int type, integer type. Spark does not understand double, it understands double type. So we have to convert int to integer type, double to double type. So I have just written a hash map. There is some hash map. So where I have written just a simple hash map. If we see an int, return integer type. If we see a double, return double type. And and then specify the true or false. So here we are hard coding the true part. So we got our column fields. So if I hover on that, you can see that we have got now array of struct field. We had array of string and string, which is column name and column data type. Using that, we created array of struct field. Once you have array of struct field, we just wrap it in a struct type, we get our schema. So just use that schema and create the data frame. So just use this schema. I'm just calling that method get the schema from column and type. We get the schema, use that schema instead of our hard coded schema. Use this schema instead of our hard coded schema. And it should work the same way. So I hope you got the difference between when to use the case class and when to use the uh, uh, struct type. Struct type we usually call as a programmatic schema because programmatically you are creating the schema. Dynamically you are creating the schema. And case classes are usually statically hard coded. You are specifying the schema. So as we can see here now, we our schema header has transaction ID, transaction ID. Cust ID was here, we got our cust ID. Item ID was here, item ID. Item value, item value. I did not print the schema. Schema we did not print, otherwise we'll get the data type as well. So I hope the things were clear. So this is mainly the Spark Scala programming to get the schema here. I hope the things were clear. The difference between uh, case class and programmatic schema. Okay. So next what we'll say is we can also specify the schema. We can also specify the schema to the data source API as well. I think we have already seen that. We have already seen that. We can specify in this fashion also. Here we are reading the data using the data source API. We are reading the data using the data source API. My mistake. We are reading the data using the RD API. We can also read the data using the data source API and specify the schema as well. I mean to say, let me show the case class where. So here, not here. We'll try to read the CSV file. As I said, when we read the data using the data source API, we can also specify schema here. If you know the schema, you can just specify schema. Schema will be your struct type schema. Your struct type schema will be used. We can use this hard-coded schema. So this is also fine. So in this case, you need not infer schema. This may not be required. Header equal to true, all those things is not required. You don't have the header, you don't have, I mean, we can comment everything. Because our data does not contain header, header and schema is specified here itself. So the advantage here is you are not discovering the schema, and I said that discovering the schema itself needs to read the data from the file system, and your data will be read 2 times. So you can avoid reading the data 2 times. If you know the schema, just specify the schema either in this fashion. Use the data source API, specify schema. It will be much simpler and efficient. Here we don't need any. I mean, the assumption here is there is no custom parsing required. So you know the schema. It is nowhere specified in any other file. Schema is not specified in any other file. You have the data and you somehow know the schema. So in that fashion, you can go with this. You have the data, but somehow you know the schema also. You just hard code the schema, read the data using the data source API, and specify the schema. But if they give the schema in some other file, then you cannot. Uh, then you cannot. Uh, you can use in that fashion also, provided they don't give the data type, because by default you can set the data type to string. So that's the idea of using the schema. This is also easiest way and also efficient, provided some customization is not required. So this is how you create a data frame. So once you have your data frame, as we saw, we only saw till now, we only saw how you can create a data frame. We never saw how the processing will be done. Because once we have the data frame, it is all about giving the queries on your data frame, because data frame we can imagine to be like a table. So getting a data frame sometimes may be tricky, because we have to do custom parsing and all has to be done. So sometimes what happens, you have to parse in such a way that let's say you have uh, 60 columns. You have 60 columns. Out of that, some column has null value, some column has garbage value, some column has some unknown values. So you have to remove all those things, or you have to put some default values to those things. So how can that also be done? That we'll see later. I mean, you don't know which columns has null value, which columns have garbage value, which columns have NA values. Some some columns. So you have to dynamically check every column and see what value it has. If it has some garbage value, you remove that, or put some some default values for the garbage value, some predefined default values. How do we do that? So I would I mean, just try that. I have an example, but also try that example. I will share the data for that. Just try that, otherwise we will see that. Now let's assume that we have done all those stuff. Let's assume that we have done all custom parsing. We got an RDD, or we just read the data using the data source API. And let's assume that finally we have our data frame. Once we have our data frame, the actual processing starts. Once you have your data frame now, so you can start processing the data. This is will be a bit simpler. So you process the data either using SQL queries, because it is kind of a table now, or process the data using Dataframe API itself. My mistake. Either you process the data using Dataframe APIs itself, or SQL query. You can start giving, because you can know that you can that the data frame is just like a table. Obviously we can give the data frame, sorry, SQL queries. Now it is only the individual choice. So if you are comfortable with SQL queries, you can go with the data frames. If you are sorry, you can go with SQL query, Spark SQL queries. If you are comfortable with the programming kind of a language, then you can go with the data frame. But still, both almost look like a relational style programming. Both looks like a relational style programming, not much of a functional style programming. RDD APIs are the processing we do on an RDD. They are more of a functional style programming. This data frames, or if you take SQL, even though there is a slight difference in the programming, but almost they look like a relational style programming. We kind of lose functional style programming. And as I said, it is the individual choice. There is no constraint that you have to use SQL queries only, or you have to use the data frame APIs. And there is also no performance difference. You will get the same performance if you go with SQL queries or data frame APIs, because any queries or any API you give, both will go through the catalyst and tungsten. So it will be an optimized code only. So there is no difference in the performance at all. So first we'll see how to give simple things using our SQL queries. So just search for Control Shift N, simple queries. Just a second. We said simple queries. There will be two simple queries class. One is data frame data manipulation language, and one more is SQL data manipulation language, DFDML and SQL DML. First we'll see the SQL part. First we'll see the SQL part. So I will explain this part. Let's see this part later, this configuration. So as usual, we are creating our Spark con. As usual, we are creating our Spark context. As usual, we are creating our SQL context. As usual, we are specifying what all configuration we have to give it to the data source library. As usual, we are reading our data using the data source library. We get a data frame. So this till here we have already seen. Now now this is our data frame. Now if at all you want to give queries on your data frame, you have to give a table name for your data frame. And this is how you give a table name. On data frame, we just call the method register temp table and give a table name. It will not do anything. No processing, nothing is done. We are just assigning a table name for this data frame. That's all. Now this table name will be used in your queries. So we had our SQL context. We had created our SQL context here. SQL context has an SQL method. We just use that method and pass all our select queries or all other queries. So here we are selecting the distinct item IDs from our sales. Once we give a query, this query again returns a data frame. Just like as I said, just like data frames are also immutable, just like RDD. Whatever RDD properties we have seen, I said that the same properties hold good for data frame also. So any transformation you do on a data frame, it returns a new data frame. So when you select some fields from a data frame, it returns a new data frame. So item IDs is a data frame. So as you can see on that data frame, you just say the show. It will show the first 20 elements as same as normal SQL. Select count star total number of records from your data frame. So it again gives a data frame. Some group by is there, customer wise count. Select customer ID count star as total count. From sales is our table name. We just say group by customer ID, order by total count. Similarly, we had seen item wise count. In our Spark, very first time we had seen the item wise count. Here we are just giving that item wise count in the select query. Uh, if we do register temp table, I don't think so. It is an action. And nothing, no tables will not be created. It will not be a table, just a name given to your data frame. Now this is your data frame. This is your data frame. So to this data frame, they are assigning a name called sales. You can just think of that. It's just a reference name. I don't think so. A table will be created in the driver. No, it is just a name given to your data frame. So this is your data frame. So similarly, as we know that item-wise count, we had to do map transformation reduced by key transformation. The same thing can be applied with your SQL query. Normal SQL queries will, it's almost same as the normal SQL query. Select item ID count star as count from sales, group by item ID, order by count. Again, it returns a data frame. You can show the contents of the data frame. So let's run this program and see the result. So it has exited code 1. Let's see what is the error. Illegal. The header contains duplicate entry. Okay. I'm saying header equal to true, and I think I have deleted the header from my sales.csv for testing purpose. Let me put back the header. So that's our result, as you can see. Item wise count, item ID 1 has been sold once, 3 has been sold 2 times, item ID 4 3 times, item ID 2 8 times. The same item wise count. Slightly the content of the file is different. Customer wise count. So this customer ID 1 has purchased 10 times. So it's the most valuable customer, most loyal customers, we can say. Total number of sales. So we are just giving the SQL query. So here also the same architecture works. Internally, the driver creates the DAG. The driver creates the stages. After creating the stages, it will create the tasks, and based on the number of tasks, and based on the number of input splits, those many tasks will be created. So the architecture we defined for Spark Core, the same holds good. So wherever there is a shuffling, so the stages will be created. So obviously we know that getting distinct item ID gives you shuffling, because all the records with the same item ID should be in one system. Only then we can get the distinct. So here also we'll get the shuffling. Group by, we have to get the total count for each customer. So obviously here also we need shuffling. Here also we'll be doing a shuffling. So wherever there is a shuffling, so we know that the stages will be created. Now, now one thing we have to remember here is, so as I said earlier, while discussing the Spark core, this is stage 0. This will say as stage 1. Stage 0 is number of tasks is equal to number of input split. Here number of tasks is how much? Is same as the number of tasks in the previous stage. That's our Spark core, actual architecture of the Spark. But in case of Spark SQL, the number of tasks in the next stage is equal to hard coded it to 200. So by default, there will be 200 tasks created. So the reason may be that Spark is usually used for processing huge data. For huge data, some 200 tasks should be a starting point kind of a thing. Number of tasks as 200 could be a starting point. I think that could be the reason. So they have just hard coded it to 200. So if this is how the configuration to specify the number of stages is, number of tasks in the next stage is specified. By default, this will be 200. I have set it to 1. It always says about number of tasks in the next stage. Number of tasks in the next stage. Tasks or partitions are both one and the same. I mean, 200 partitions will be there. As a result, 200 tasks will be created. So if I comment this and then run this program, so you will see that. So as of now, you can see that the number of tasks, task ID 6, task ID 7, not much tasks are created. I think this is the task ID 9. Some 9 tasks are created. Now I have commented this. Let's see how many tasks it creates. Tasks are nothing but some pthread objects. So as you can see here, task ID 149, 178, 200, 199. Again, next number set of tasks. 269, 300. As you can see, more and more tasks are getting created. 400. Because wherever there is shuffling happens, 200 tasks will be created. So as you can see here, totally around 606 tasks are created. Most of the tasks will not do anything because we don't have that much of data. They are just being created and destroyed. That's all. So since distinct will do the shuffling, customer wise count do the shuffling, item wise count will do the shuffling. So 3 times we are doing shuffling. As a result, 200, 200, 200, 300 tasks will be created. As I said, Samir, I don't have a clear idea why 200 tasks. Possibly the reason is that is a starting point, because Spark, they know that it is for processing huge data. It could be the starting point. Just they have hard coded it to 200, but they have given that's the default value, but we can always override with the any value here. So earlier as you can see, there were 600 tasks. 3 times shuffling were there, hence 3 times 200 tasks was created. Total is 600 tasks. some other tasks are also around some extra 6 tasks are being created. So that we have to keep in mind. Number of tasks in the next stage will be always. If I try to save that, so I will comment it as usual. So if you want to write the data to the file system after processing the data, you don't usually say show. We know that show is an action, but its show is only used for display purpose. Sometimes we have to save the data back to the file system, so we can use in this fashion. Customer wise count, write dot format, customer dot format. Just like read dot load, we have the data source API, read dot load. Here we have write dot save, write dot save. Then which format you want to write in, and whether we also want the header to be part of your file. Such things also can be here. So if I run this program, it should save the data. Let me delete this, and let's check whether we are giving the path as well. We are giving, otherwise it would have thrown error. So it has exited with code 0, and you can see that CSV output is again created. But you will see that, so we are having, okay, sorry, my mistake. Why 4 part files? So actually there had to be, the reason is, I will just show you. Let's remove this order by count. Group by customer ID, group by customer ID. Then let me run this program once again. So now it has created the CSV output file. Let's see what is the. So as you can see here, as I said, by default there will be 200 partitions. Since there are 200 tasks, there will be 200 partitions. When we save to the file system, it will create 200 part files because there were 200 partitions, because of which 200 tasks was created. And when we save the contents of those tasks, each task will write to the disk as its own part. So 200 part files will be created. So only because our data is very less, every file will not contain the data. Only few of the files will contain the data. If I go to the CSV output, all the files will be empty. So all the files will be empty. You can check that. Most of the files will be empty. So it doesn't have anything. Because we had set header equal to true, it has just set the header and count. Customer ID and total count. Only few files will contain the actual data. So if I so as you can see, part number 170, part number 171, part number 172, and part number 173. Only these three files contain the data. So these four files contains the data. Others are just dummy files because there was no enough data. So just you have to be careful about when you are saving the data, check how much data you have. So this 200 may not be useful. So it by default creates 200 files, only even though there is lesser data. So you can see that these four files has the actual data. Customer ID 1 has purchased 10 times, customer ID 2 has purchased 2 times, 3 has purchased 1 time, and 4 has purchased 1 time. So that's the reason I mean, we got our customer wise count, but the number of files is 200 because by default 200 partitions will be created. Now earlier we saw only 4. Earlier we saw 4, and I removed from here, I removed order by count. So I will put that back. So when we do order by count, we got only 4 files because order is a global order. I mean global sorting. Order by is global sorting. If we do sort by, it is each task internal sorting. Order by, just like high we have. Order by is a global sorting. Sort by is a, a local sorting. So when we do a global sorting, all the records with the same count will come to one file. These two will come to one file because we are doing a order by count. So here the count is 1. So these two will come to one file. This will come to one file. This will come to one file. Remaining everything will come to one file. So these two as one file, two file, three files. Remaining everything will be coming as one file. So that's the reason when we use the order by. So then when we use the order by, because it has to bring the data together so that it can compare the count. So again it will bring everything together. So that's the reason we were seeing all the 4 files. So I hope you got the difference why when we use the order by, the count was 4. The file counts was 4. not 200. I hope you got the idea there. So I assume it was clear. I assume it was clear. Now in a similar fashion, we will see. We saw the normal queries here. You can also give the join queries. You can also give the join queries using the SQL. Just like you give the queries in your normal RDBMS SQL queries, here also you can give the same. So let's see this later. This again it is for the broadcast. As usual, we are creating our Spark context. We are creating our SQL context. As usual, we are reading our data using the data source API. We are reading our JSON data. Here is a question. Without order by, the number of file would have been 3. So this is what you are asking, right, Atira? Without order by, the number of has to be 3. No, but we saw 4 there. We saw 4 files. We didn't see 3 files. We saw part 001, 2, 3, and 001, 0, 1, 2, and 3. So it is these two will be in one file. This will be in one file because the count are different. This is one file and all other files will be one file. So totally 4 files. 1, 2, 3, and rest as 4. This will be one more file which will contain nothing. Which will contain nothing. Yeah, just will. I hope we'll go to the join example. So this is where Spark is more useful whenever we are joining the data, because our data source API, once we use the data source API, we know that we can read data from any structured data, any structured source. We can read a JSON data. We can read a CS1. Your sales data may be a JSON data. Your customer data could be a CSV data. It doesn't matter because once we read it, you get a data frame and you can represent that data frame as a table. So once you have a table, you just have to give the join queries. That's very much helpful when we have such kind of a stuff. It makes the joining very simple. Otherwise, you have to do a lot of stuff just to join two different data structure data. So here it is. To showcase that, we can see that we are reading our data, sales data, and we are reading our sales data, which is in the form of JSON format. Hence, I'm using the JSON format. We register that table. Similarly, we are reading our customer data now, and our customer data is in the form of CSV file. So we have our sales.json This is our JSON data. Then we have customers.cs. It is a CSV data. So we have to join these two data so that we can include the customer name also along with the transactions. So how can we do that? So Spark makes it a bit simple because both data could be represented as a data frame, and once we have the data frame, join becomes simple. So we have our customer data frame, we have our sales data frame. Again, the concept remains the same. Internally, the shuffling will happen. Internally, all the records with the same customer ID will be brought to one place. Then the actual join will happen. The concept remains the same. Only thing is we are doing with the help of our SQL queries. Yes, we can perform all joins. Here by default, it does a simple inner join. Select star from sales, join customer. So if you want outer, we just have to say outer join. So if you want left, left outer join. So if you want to say right, you have to just my mistake, sorry. Here, left outer join. You have to say in this fashion or outer join. So by default, it does a inner join. Select star from sales, join customer on condition is customer ID is equal to sales ID. So when you give the condition, by default it will do inner join. If you don't give the condition, if you don't give the condition, by default it will do Cartesian product. So that just keep in mind. If you don't give any condition and you just say sales join customer, it will do a Cartesian product. If you give a condition, by default it will do inner join. Rest you have to explicitly specify. Outer join, left outer join, all those stuff we have to. So as we can see here, once we have our data frame, we did a join normal SQL query. As I said, any operations on the data frame, again it will give a new data frame. So customers join sales is one more data frame now, and we can do a show on that. Similarly, if you want to give some nested query, you can also give that. So if I want get all customers, get all customers whose total purchase is greater than 600. I mean, I'm not so good at SQL query because there could be as complex query as possible. I haven't tried more complex queries, but it is most of the SQL experts should be able to write I mean complex queries, and Spark do support it. Now we want to get all customers whose total purchase is greater than equal to 6. So here we are using our inner nested query. So our internal query is find out the total amount per customer. Select customer ID. My mistake. Our inner query is select customer ID, compute the total amount per customer. Total amount per customer from sales is the table name that we give to our data frame because we have to register it as a temp table. We just say group by customer ID. So this will give total amount per customer, we know that. This will give total amount per customer. So that we keep it as one more table. Inner table we can keep it T2. So outer query just says select customer ID, select customer ID, total count, total amount from T2, where we just say T2 is total amount is greater than or equal to 6. A normal SQL nested query. So we get our one more data frame. It returns a data frame with with all customers whose total purchase is greater than or equal to 600. So we can again give a table name for that data frame. We got a new data frame, we can again assign a table name for that data frame. We'll say that as a high value customer. Any name you can give. Now I also want the name of the customers. We also want the name of the customers. Obviously, we can join this table with the customer table. So we select star from customer, high value customer, which has all the customer IDs or customer details, sorry, transactions which is greater than equal to 6. We just join with the customer ID and we get the customer name also. So we'll get to know the you can also have a mobile or address or email ID in the customer data. So we'll actually get to know who all are your high value customers. So we can run this. It will just join the data and give the, as usual, local code source main resources sales.json. JSON is a I mean sales is a JSON file now. Code source customer. Customer data is a CSV file. So we have two different data and we are able to join that data. Let's see how the join works. So we should get this data. Customer ID. So as you can see here, customer ID 4 and customer ID Brad and John are the person who purchased the amount whose total amount was greater than or equal to 600. So these are all most valuable customers. These are all the most valuable customers. It's a normal SQL query. I mean to say once you have your data frame, giving queries should be simple. It all depends on your SQL expertise. Almost all the SQL queries, the way you give in SQL, the same way it works in Spark also. So I hope that was clear. So I think we will wind up the session here. In the next session, we will see how to use we saw SQL based processing. We'll see the same processing using data frames. Then we'll see Hive integration. Then we'll see user defined functions, user defined aggregate functions. Here also we have two things uh, before here dataset API based, Dataframe API based. User defined aggregate functions. We will see these things. Probably we may not be able to cover all the things in the next session. Probably next session we will do. This is the remaining things that we have to do. Hive integration, user defined functions, data frame APIs, processing, and data sets. We have to see data sets. So I will explain data sets just before explaining the user defined aggregate functions with the data sets. So let's wind up the session here, and let's continue tomorrow same time. Thanks everybody. Have a nice day, and good night, others. Thank you.